Okay, now tell me that what will be the Laplace transform of the function e to the power st. So we apply the formula here, and that is 0 to infinity e to the power minus st into e to the power st into dt. So minus st and plus st, because bases are same, so powers are added, that makes it e to the power 0 into dt. So e to the power 0 is 1 into dt, so its integral is t from 0 to infinity, and if we apply this, then it becomes infinity. So there is an undefined Laplace transform of e to the power st. So very basic question this is for general knowledge. Okay, now our next topic is in the Laplace transform to find out the Laplace transform of the trigonometric functions, and that is Laplace of sine theta can be any angle, and Laplace of cos of theta. Identity is given by e to the power iota theta equals to cos theta plus iota sine theta. You have to remember that cos theta is the real part of this equation or this identity, and sine theta is the imaginary part, just like alpha plus iota beta. So this is the real part and this is the imaginary part. So for theta you have to replace a into t, because we have to deal with e to the power at. So if you replace, it doesn't matter in this formula, it becomes e to the power iota into at cos of at plus iota sine of at. Now we proceed by applying Laplace on both sides. So Laplace of e to the power iota at is equal to Laplace of cos of at, because Laplace is a linear operator, so it can be applied term by term, and if the constant is given, like iota is a constant, so it is independent. Laplace or any constant is independent of the Laplace operator. So in short, you can say that Laplace is a linear operator. So iota Laplace of sine of at. Okay, so what we have to do, we will solve this only left hand side, and we will come to the conclusion what is the Laplace of cos of at and what is the Laplace of sine of at. So we start from the left hand side. So by definition, left hand side is e to the power iota at. This time we have iota a as a constant. So 0 to infinity e to the power minus st into e to the power iota a into t into dt. So powers should be added because base is same. So 0 to infinity e to the power minus st plus iota a t into dt, and you have to take t as a common variable. 0 to infinity e to the power minus s plus iota into t dt. Now you can integrate, because minus s is a constant, iota is a constant, a is also a constant. So constant is always divided when exponential function is integrated. So its integral will be e to the power minus s plus iota a into t from 0 to infinity divided by minus s plus iota a. So now in the next step you will apply the limits of integration in this. So to avoid the undefined value, you have to shift this exponential function in the denominator. So in the denominator, if it is shifted, and if I would take this as common negative sign, then s minus iota a. Now I can shift easily this exponential function, so that becomes 1 over minus s plus iota a into e to the power s minus iota a into t, and now I can apply infinity, and now I can apply the 0 term. Okay, first I have to take this as common value, and 1 over e to the power s minus iota a into t, s minus iota a into infinity, minus 1 over e to the power s minus iota a into 0. So 1 over e to the power minus s plus iota a and 1 over e to the power infinity into some value constant is equal to 1 by infinity. That makes it 0 and minus 1 over e to the power 0. That makes it 1. So 1 over minus s plus iota a into minus 1. So if minus 1 is multiplied with the denominator, then it becomes 1 over s minus iota a. Now in the next step, what you have to do, you have to, because I have told you that you have to sort out, you have to find the Laplace operator term by term. Cos of theta, cos of at has a separate Laplace operator, and sine of at has a to t has a separate Laplace operator. So what you have to do, you have to multiply it and divide it with its conjugates. S minus iota a is multiplied with s plus iota a, its conjugate, and s plus iota a. So that rises to s plus iota a divided by a minus b into a plus b. That makes it s square minus iota square into a square. So s plus iota a divided by iota square is minus 1. So minus into minus 1 is, I would write it as minus 1 into a. So s plus iota a divided by s square plus a square. Now I can write it term by term, and that is s divided by s square plus a square and iota into a divided by s square plus a square. So this is the real part and this is the imaginary part. Your real part says the Laplace, it represents the Laplace transform of cos of at, represents the Laplace transform of sine of at. So you can write it here that Laplace transform of cos of at is equal to, by seeing this you can say that the real part is s divided by s square plus a square, and the imaginary part is Laplace transform of sine of at is equal to, by looking at this you can say that it is a divided by s square plus a square. Don't write iota with that because imaginary part, iota is the imaginary part, and so this is the Laplace operator of cos of at and sine of at. And now a can be any constant. If cos of 3t, then it means 3. So s divided by s square plus 3 square is 9. S divided by s square plus 9. And again, if you have sine of 70, then it means a divided by s square plus 49. So this is all about the trigonometric functions. Also, you can find out the Laplace transform of hyperbolic functions. At hyperbolic at is, you have to find it, and also side by side, if you know the technique, then you can solve, you can find out both of its Laplace transforms. So sine of hyperbolic at, sine of hyperbolic x is the formula. Sine of hyperbolic x has the formula e to the power x minus e to the power minus x divided by 2. So here x is at. So you have to replace Laplace of e to the power at minus e to the power minus at divided by 2. And because Laplace is a linear operator, also the cos of hx hyperbolic x is e to the power x plus e to the power minus x divided by 2. So Laplace of e to the power at plus e to the power minus at divided by 2. So I am just solving one, and you can also solve by your own self. So Laplace of at is, because Laplace is a linear operator, so 1 by 2 becomes constant and it can be applied term by term. So e to the power at minus Laplace of e to the power minus a into t. So you know that by using the formula, basic formula e to the power minus st into e to the power at, that makes it the Laplace transform of 1 over s minus a, and that becomes minus a, so it means that it has s plus a. So what you need to do, you have to take the LCM, and that makes it s plus a minus s minus a divided by a plus b a plus b into a minus b. That makes it s square minus a square. So you can see that 1 by 2 s plus a minus s plus a divided by s square minus a square. So 1 by 2, simple, by using similar technique, you can also find out the cos hyperbolic. It is 2 into a. It is 2 into a, and by using the similar technique, you can also find out cos hyperbolic at, and its Laplace transform is, you can do it by your own self, and that is s divided by s square minus a square. So this is all about the Laplace transform, and it has a very vital role in solving the differential equations. So we will study in the future. So thank you so much. If you have any questions, if you have any queries, you can ask me in the online lecture, and I hope that you understand this lecture thoroughly. So thank you so much.